is because it builds on itself, and it's why it's so important that you stay caught up on your homework and that you're coming in to see me when you're having questions.
Just keep going.
It's not like you're going to be here next week.
What?
Why don't you teach us the stupid hand trick?
I
It's
just
so
love
easy.
this hand trick.
That's the greatest thing I've ever heard in my entire
The
life.
stupid hand trick. You're calling the stupid hand trick, but you want me to fix the
I'm
teacher.
calling it stupid because you didn't teach it.
Well, I tried to.
Why?
I showed second hour the stupid hand trick, and they thought it was stupid.
What
And
hand
I
trick?
showed calculus the hand trick, and they're like, "Don't teach that to people. It's confusing."
I'm like a 4-year-old. That helps so much.
And so
See,
here's the hand trick.
That's it. I'm teaching that.
If you, I taught Trevor this for the last test. It didn't seem to help that much.
Hey, I did what I did get though is because of that.
It only works for the first quadrant. If this is 0, you can kind of imagine this would be pi halves, yes? So look what happens in the middle. There's 3 of them. So this is pi 6, this is pi 4, this is pi thirds. Yes? So let's say you want to know pi thirds. So you put down pi thirds, and the number left on top is your cosine, and the number here is your sine. So cosine, you have to remember pretend that there's a 2 on my hand here. That's the part that everyone hates. They're like, how can I pretend there's a 2 on my hand?
Match.
Pretend there's a 2. So then your cosine is 1/2, and your sine is square root of 3 over 2. What about pi fours? Square root of 2 over 2, square root of 2 over 2. Pi 6, square root of 3 over 2, 1/2.
I'm pretty sure I'm ready for my no calculator.
Because, just like my trick of how to remember the unit circle, you have to speak the square root of all top numbers. Split them over 2. So it's kind of like this.
I still don't like that one. Can I go take my no calculator? Like, seriously, I want to take it now.
That only works for quadrant 1, but then you still got to get it to the quadrant, right?
It's just flipped over, and then it's again.
I'm sorry. People thought it was stupid, and they said don't teach people that. It's confusing.
I told you should have taught this class.
And then I just gave up. I
You
just learned it in a conference I went to in November. Like I just learned the trick in November, and I was like, oh, I can't wait to teach my kids. So I came to calculus the next day, and I was like, hey guys, let me show you this awesome trick because they know trick already. And they were like, that makes no sense. Why do you have to imagine so much? Because I was like, this kind of looks like 90 degrees, and then I was like, and there's a 2 on my hand, and they're like, that's too much remembering. Like that's just stupid. No, that's cheating. But it's not cheating to do this during a test. And there's some trick, I didn't really figure it out, but he said something about tangent is y over x, so if you flip your hand over, tangent, is that true? Tangent of pi 6 is 1 over the square root of 3, is that true? Because it's y over x, so you flip your hand that way, and so tangent of pi thirds is square root of 3 over 1. If you flip your hand over, the 2's gone. How about that? I didn't show him that. I'm sorry I didn't teach you the trick.
That could have helped.
Because it's been on recording the entire time.
Yeah.
Now you know. Good news, you can still retake the test. So. I'm sorry, they told me it was stupid. I thought it was cool. Everyone said it was stupid. Second hour said it was stupid.
That's
Maybe
a
second hour is just.
And so I gave up.
Can you see second hour's test scores compared to ours? It's probably because of that hand trick.
No, they don't like the hand trick though. You asked
I
them.
bet they probably use it.
They're sitting there saying, what is
The first day that I taught the unit circle trick.
I was like, you didn't show us this.
I know, because they told me it was stupid. I think you only like it now because the other way is spelled too. Because they were like, I like the shortcut for the unit circle way better. But then now that you took a test and you're like, crap, that didn't work so well. Show me a new trick. They didn't like the new trick, so I'm sorry. I apologize. It works. I think it can be kind of confusing, but whatever. Let's do this though. We gotta still do other stuff. We've talked about what A does. It changes the amplitude. We talked about what B does. We haven't talked about adding or subtracting. Adding and subtracting inside of a function. We've always talked about translate a function left and right. That still happens, but it's kind of weird with the trig function. Like it's not just it translates it 2 units to the right. You have to use the b and the c together. And so if you wanted to figure out, normally if we were just graphing normal sine, we go from 0 to 2 pi. If you have a b and a c there, you have to change what you go to. And so if I solve this for x, do you agree I could just add c, maybe over here, I could divide by b, and I get x equals c over b. So instead of starting at 0, like this kind of represents your translation, and I think it makes more sense when we actually throw some numbers in there. But that's how you figure out what it goes. It doesn't just go c units, it goes c over b units. And then where does it end? Well, normally it ends at 2 pi. If we solve this one for x, I would get 2 pi plus c. I would divide by b, and I get that it ends at 2 pi over b plus c over b. And I separated it just for the reason, what does 2 pi over b mean to you? That's the period. So it ends at wherever the period ends plus that translation. And so you could say, like, what if I wanted to shift my graph pi thirds units? Well, then this would be pi thirds, and it would end at like 2 pi plus pi thirds if I'm shifting it pi thirds. The good news for you is I'm never going to make you graph by hand a horizontal shift because it gets a little crazy. We are going to graph on the graphing calculators, and we are going to be able to tell our shifts. We're just not going to have to graph these. So I want you to understand this, but I also want to kind of tell you up front, you're not going to have to graph these by hand because they get a bit crazy sometimes. But instead of calling it a translation, just like we don't call the stretch or a shrink, we call this a phase shift. And so when the directions say, give me the phase shift is always c over b. What's wrong, Trevor? Oh, kids. Sorry. I thought you were written this down forever ago, but you were just yelling at me about the answer. That's a lot. Miss Hodge says we're getting 6 inches, but nothing I found said that. And somehow Miss Hodge has secret things that always tell her we're getting more and more. She always ups the number, I'm telling you.
She was right at the rate right now. No.
Well, if you feel like not driving, you could just stay here. We could just do pre-cal.
I don't ever get me out of work yet.
Can I go?
You work at bars beyond
Okay, so I want to summarize what all these letters mean, and then we can do some examples here. Maybe. Come on, smart word. Stay with me. The other day when we started this, I gave you this big formula with all these A, B, C's, and D's in it. And we've talked about everything but D, but we're going to talk about D in just a second. And you need to know what all of these do in terms of answering questions. And so sine and cosine, what these things do are work the same for both sine and cosine because they're both very similar graphs. So whenever A does the sine, it does the cosine, and B and C is D. Next week we're going to graph all the other ones, tangent, cotangent, secant, cosecant. They have their own sets of rules.
Is there anything I can do to make the phase different to where it's still like because I look at that and I don't it's like a cent, what's a cent? And I'm like, oh my goodness.
I feel like it gave you the time.
I always write sine like this. So to me, like sine is separate than A. You know, like to me, like I type it like that. But like A, to me, cosine is always joined together when I write it. So that's how it's separate to me. But you could just do like times, or you can even put like parentheses. Yes, dear. I write these notes?
Yeah. Like, did you do them all like your first year?
Well, I've taught from this. I think this is the third year I've taught from this book. So the first year I had this book, I typed all these notes myself, and then every year I go through and kind of tweak a little bit, add a little bit, change a little bit.
Like when you were writing, just writing every day.
Pretty much, my goal was my goal was always to say a chapter ahead, but it never happened. I was always like a day ahead. So, but I always did the homework. So I've done every homework or problem I've ever assigned in this book to you, and I usually did it like whatever homework I assigned to you today, I did the day before, because I always like to make sure that they're good homework problems and that they're what I have in the notes or what's in the homework. But yes, I always had a goal of being a chapter ahead, but it never happened. I was pretty much a day ahead at that time. So that's what I've been doing on my prep now. Like college algebra, I'm teaching for the first time this year. So today on my prep, I'm going to make notes for Monday in college algebra because, you know, who needs to be more than a day ahead?
You suck, like lost.
Are you planning something?
No.
No, it's like my biggest fear to lose my notes, because especially because I just save them on a flash drive. And so then I have moments of like, where's my flash drive? Like I protect it with my life. But I have an external hard drive that I back up. I try to back it up every week, but sometimes I don't. And so I have it backed up on the external hard drive. I have it backed up on the C whatever drive on the computer because I do have terrible fears of losing all my notes. But I do have backups. Miss Bai takes her flash drive home every night because of the fear of the fire burning the school down. So she takes her flash drive home every night, and I'm like, if there's a fire, whatever. Like, it really is going to burn the school to the ground. Hopefully it doesn't start in my room. That's my goal. But yeah, she takes it home every night. But it's too much stress on me. If I take mine home every night, like every time I take my flash drive home, I like check like 3 times. Is my flash drive in this? Is my flash drive in here? Before I leave the next morning, is my flash drive in here? Like, here's my flash drive here. Because you don't, like, Miss Bai and I both have moments of thinking we've lost our flash drive, and it's, like, heartbreaking because your whole life of teaching is on a flash drive. It's stressful. So, yes, I made all these. I've also made all Mr. McClure's algebra 2 notes, which are now Mr. Stewart's algebra 2 notes. So, there's lots of backups for that, because I still have them, and Mr. McClure has a copy, and Mr. Stewart has a copy, so we're good to go on that one, unless the school burns down. So, yeah. If you ever want to give a teacher a heart attack, steal their notes. My flash drive. That would be terrible, Benjamin.
Like, it's so easy to wipe stuff now that I put stuff.
I learned that on Breaking Bad.
So, like, you can take, like...
I just watched the episode with Bagman. Yeah, I just watched that episode. That's where I'm at, that episode. Amplitude is the absolute value of A. It gives you your Y values. Hopefully we're feeling okay with that. The period is what hopefully you did on your homework yesterday, is 2 pi over B. The new part is C. And again, I'm going to write this 2 ways. One way we can write it is we can say your endpoints of one complete cycle are always going to be whatever bx minus c equals 0 and bx minus c equals 2 pi happen to be. If we were graphing by hand, it would be really important that we could find those 2 endpoints. When we graph on the graphing calculator next week, I'm going to show you what I mean by that a little bit more. Really, all you need to know is that the phase shift will always be computed as C divided by B. And notice, just like when we do translations with normal graphs, you take C, even though the formula says bx minus c, right? Because remember when it says like x minus 2 squared, it's really to the right 2, not to the left 2. It's like the opposite sign. What you think? I don't know if you remember that or not. So we got amplitude, we got period, we got phase shift. The only letter that we haven't talked about is what D does to that problem. What does a number added or subtracted outside of a function do to the function? Yeah, it's a vertical shift, and their book never even talks about what D does. Like it writes it like this, but they just assume that you all remember that a number added or subtracted outside of a number is going to be a vertical shift. So if there was a 3 3 out here, it means it would take your whole graph and move it up 3 units. There was a -2 out here, it would take your whole graph and move it down 2 units. We don't do those a lot, but they do show up every now and again. So a good amount of your homework today is just giving you equations and asking you, what's the amplitude, what's the period, what's the phase shift, what's the vertical translation, and just asking you to know that stuff. And on your test, you're going to have questions like that. You're not having to graph those. Okay, so let's do one of those. I put my little graphics in here to try to make you feel better, because everyone hates this. It's not so bad though, right? You don't hate it. You like it. He's like having an idea. He's like, what's happening? Oh, I get it. Because then he gets it, the light bulb. Oh my gosh, quit looking out the window. It's not going to help us. It's still snowing. No matter what happens, it's still snowing and you still got to go home or work in it or wherever you're going.
Nowhere.
How are you going to get home to begin with? Before the snow happened, how are you going to get home? When you came to school this morning without your mother, how were your plans to get home?
Basically, my school is like, I want to go to school for years whatsoever. Sorry. Steal Finn's truck was another option, but I don't drive in snow. And the last thing I'm going to do is ride his truck and that'd be so I figured probably is what it was.
So you're just trying to get us one Friday.
I just don't want to go. This is dumb.
Yesterday and on the homework quiz you just took, you had to do amplitude and period. The only difference now is I can throw in a C value here to make things more exciting. What's the amplitude of this problem? 1/2, the number in front. You got to know the formula for period. Period is 2 pi over b, and what's b in this problem? Which means the period of this is actually just 2. We're going to graph one like this in a minute where the period doesn't have a pi in it, and that's because there's a pi in the problem already. But b is still just b, 2 pi over b, right? You're right, it has a -1, but that has nothing to do with the period. The period is 2 pi over b. The -1 is the new part, which is your phase shift. And you just need to know this formula. The phase shift is C over B, and you always take the opposite sign of that. So C is really just 1. So the phase shift is 1 over B, which would be 1 over pi, which is a really weird phase shift, which is why I don't make you graph these. If we were shifting it like pi halves, that's not a bad one to do because we can kind of think about that. But to shift it 1 over pi is going to give you really weird numbers. Yesterday, there was not pi in the problem. Yesterday, it was like x over 2, right? And we just used the 1/2. Pi is just the numbers in front of it, just like if it was 3. Does that make sense? So the pi's didn't cancel out, because there wasn't a pi yesterday. And then what would the vertical shift on this one be? Vertical shift is a number added or subtracted outside the function. Is there any number added or subtracted outside the function? No, which means it's not moved up any. So you could say none or you could say 0. But because it asked you for it, make sure you tell me something, right? That's a point. So I'm going to say 0 or you could say none. Okay, that's really all you need to do with phase shifts. I'm going to show you a picture later to kind of try to help you visualize it a little bit more. Again, you're not going to be graphing this. Okay? But we are going to graph on the homework today, but we're going to graph the same kind of stuff we've been graphing because, you know, we should do a little bit more practice. So let's do one. I've got 2 more examples, this and 1 more example. I just wanted to graph one with you that had a pi in it to begin with, just to show you that sometimes your x-axis doesn't have pi in it. And again, just because next week we're going to move on past sine and cosine, and so I wanted to spend one more day on graphing before we move on to the other trig functions. But anytime you're graphing, you should start with the amplitude, you should start with the period, you should pick those points that you need to pick. So what's the amplitude on this one? Right, it's the absolute value of A, which means it's 1, which means my graph is not stretched any. It's just a normal. But what does the negative do to my graph? Yeah, it flips it over. So I hope that when you think of cosine right now, you think it starts up here, it goes down and kind of makes that U shape. Because it's negative, it's going to flip it. So now it's going to start down here and it's going to go up. So it's going to go the other way. The period is 2 pi over b. What's b in this problem? 2 pi. Which means the period is 1. Your period can be anything. It could be like 17 pi. It could be 1. It could just be pi. People kind of get freaked out when it's just a number. But no matter what this number ends up being, that's how you pick those 5 key points every time. You start at 0 and you end at whatever that number happens to be. Sometimes you get some weird fractions in between, but whatever that is, you take half of it and you take half of it again. So when I take half of 1, I know that that's a half. And when I take half of a half, I know that that's a fourth. And someone asked me yesterday how I got that fourth point, I guess it is. You can just always add these two together and it'll always give you that third point. Or whatever this is, like that's what you're breaking it up in. So like this is 1/4, this is 2/4, so this would be 3/4. Sometimes they're easy to figure out and sometimes they're harder. Like if there's a weird one on your homework, I think you end up breaking it up into like pi-8ths or something. But it's still just breaking it up. So I just want you to see that because there's a pi already in the problem, we don't need to pick pi here. And if you did all your homework yesterday and you're feeling better about this stuff, you should know what's going to happen when I pick these points. And if you know the pattern for cosine, it's the same every time if you pick the right point. So you don't have to do all the plugging in. If you need to do all the plugging in, do it. But you maybe shouldn't have to. When I plug 0 in here, I'm going to get negative cosine of 2 pi times 0, which is still just 0. You with me on that? 2 pi times 0. And what is the cosine of 0? Yes, you almost said it. 1, but then there's a negative. Normally, cosine starts at 1, but it's negative, so it starts at -1. Where does cosine usually go after that? After -1, where does it go? 0. And so if you know that, you can just fill it in. If you want to make sure, check the next one. If you plug 1/4 in here, 2 pi times 1/4, the 2 and the 4 are going to leave you with pi halves. And is the cosine of pi halves 0? 0. That's why we spend so much time graphing sine and cosine, is because the idea is you should know what's going to happen next. It normally starts up at 1, it goes down to 0, and then where does it normally go next? Yeah, normally it goes down to -1, but because we're flipping it, it should go to 1 next, right? And so again, I could check this. That's going to be cosine of pi when I plug 1/2 in there. And the cosine of pi is -1, and negative of -1 is +1. In second hour, they say, once you do the first two, you know what's going to happen, because they just know it's going to alternate. And I hope that maybe we're there. And if not, pick the points. You can do the math every time. Someone asked me in second hour today, should I be in degrees or radians on my calculator? And I might have screamed at them a little bit and said, you should not be using your calculator! Because I don't know why you're using your calculator. But you could use your calculator. But just know when we have a test, I'm going to expect that you could graph without a calculator. Because these are nice points, right? When you pick 3/4, you should get negative cosine of 3 pi halves. And these are radians, so you should be in radian mode if you're using your calculator. I might have thrown Zane's calculator across the room. Maybe. Because he's typing everything in his calculator, and he's driving me crazy. I told him he's too reliant on his calculator, because he's the one that said, as we were doing this problem, should I be in degrees or radians on my calculator? And I said, you shouldn't be using your calculator! And he kind of startled him. And then later, he asked me how do you do this? Something like that. And I said, you are too reliant on your calculator! And I took it and I threw it across the room, because he started to type that in his calculator when he didn't know how to do it. And so I threw it up here. And then Mason got up and got it back for him and put it nicely on his desk. It didn't break, it's good. Should go back to 0, yes? And for cosine, you end where you start. So if you started at -1, you should end at -1. Because every time, if it starts up at 1, it makes that little U shape and it ends up at 1. Just like sine starts at 0 and ends at 0. Like you're going around the whole circle. You're with me on this? You're not with me on this?
Are we going another way?
Yeah, and my directions today on the homework says graph 2 complete periods. So I always graph 1 positive and 1 negative. If you want to graph 2 positive, you can. But if my period is 1, I'm going to go to 1 here, and I'm going to go to -1 here. And every time I break it up the same way I break up my graph. So this would be 1/2. And I don't ever label those, you can, but I just break it up into equal parts. So this would be -1/2. And I'm just going to label that 1 and -1. And no matter how many periods they make you graph, once you graph 1, the idea of being a periodic function is it just repeats itself. So because it's negative, it's going to be opposite. So it's going to go down here first, back to 0, then it goes up to 1, back to 0, down to -1. And remember that these are smooth curves. I don't want to see sharp, jagged edges on your graphs. To make sharp, jagged edges, I will take points off your test. And I will say, no sharp edges! But on your test, I give you graph paper, so it's easier to make nice smooth curves because you're not drawing it yourself, right? Because sometimes it's a little sketchy when we're drawing it. And the great thing about cosine is it's an even function, so it's exactly the same over here. So I just automatically graph those exact same points from my chart, only negative. And I think that this should look something like that. And notice, my graphs for sine and cosine, they always look the same because I make my x-axis go by whatever the period is. So it's really super important that you label the x-axis. Because if you don't label the x-axis, then you're just drawing the graph up. Okay? So do you have the assignment sheet? Okay. I don't think I've given anyone else one, but you and Noah. All right, I got one more example. This one's from your book, so it has a picture, so you don't have to write all this down. I'm going to show you what I would write down. If I was writing this in my notes, I would just write this down. Because if you write down number 31 from page 392, then you can look in your book when you're looking at that problem. Because on your homework tonight, you're going to do like number 30 and number 32, so they're just like number 31. If you want to try to draw that picture, you can, but I think it's kind of crazy. So because you can tell me I should have printed those out. But the copy is broken. Blame Miss Sullivan. She's not here to fix it.
She did all so much to fix it.
I had to go all the way to the junior high level.
You're not something.
ECA lab quiz and Colton's progress report.
Although you could have been like, oh, hey, Colton brought a progress report, I'm going to make his day better, and it's Valentine's Day, and we're going to support the guy that killed people.
So, these problems, they're going to give you the equation, and they want you to state the amplitude of the period. We've done that. But the difference is, now they want you to look at a graph and tell me what the x and the y-axis are going by based on the amplitude of the period. So it's kind of a test to see, do you understand what the period is and how it reflects on the graph. So step 1, let's find the amplitude and the period.
So I zoned out. Like I told Astra that she said she zoned out. Just kind of in the back here.
I said maybe you want to write down the top line and maybe not the graph because it'd be hard to draw the graph, but you don't really have to write down all the other stuff. I think you should write down this and then this stuff.
I thought you were going to go.
How do you feel that you know
I don't care.
That's scary.
No.
It's just, oof. So, the amplitude of this would be what? Quit looking at the snow! I'm gonna throw a pin in a minute.
Yeah, it has been the first time.
It will be. So it would just be,
We wonder why second period has so many more A's, right?
As a, okay, well, you actually complained about them a lot, boy. And it was snowing during their class. And it's like, how? Okay, not junior.
They're juniors also, just so you
They're
know.
children too, and if it was snowing in their class, they would.
Alright, I'm just gonna do this because I've given up that anyone's listening, so.
But just
I think
you
that
don't.
class was stacked. Let's look at the top.
No excuses. You can't just blame it on the stacked.
That's the very first period of the day, so there was
No, it's actually second. But
second, so.
Yeah, and they knew the trick, so that is a stack squad.
the amplitude should tell you the y-axis. The amplitude tells you how high and low your y-axis is going. But don't tell me that the y-axis is going from 3 to -3, because it's really going one step higher. You agree with me on that? Because you have to tell me determine the window. The window means how high is it from here to here, right? Not just how high is the graph. So they want you to, remember on the homework yesterday, like it said, make your graph -3 pi to 3 pi and -4 to 4 or something. They want to know how high is that graph. So the amplitude should tell you that that's 3, so your window would be -4 to 4 on the y-axis. Please don't talk about the window. Look out the window as much as you want, but don't talk about it for the few people that actually want to listen to do the homework. Because on Monday, when you're like, I have no clue how to do these, I'm going to remind you that you were staring at the snow when I was trying to teach you how to do this problem. And I know you're not going to do your homework anyway, but for all the other people. The period is pi. You need to know what one period of cosine looks like to determine how many periods of cosine are graphed here. This is negative.
We have some weather-related announcements. The girls' sectional at Speedway tonight is still on. The Eagles play at 7:30.
Is that one period of
We're going to
cosine?
move the bus time up to 4:30.
Wherever it
But
starts,
the Eagles
it
girls'
ends.
sectional is still on. The wrestling Sim-State tomorrow at Evansville is still on.
So that's two
obviously, good luck
periods,
to the
which
girls
means
tonight. Good
how
luck to the
long does
freshman
this
Kyle
have to
Schaefer
be?
tomorrow as he goes down to the Sim-State
This
wrestling
is
meet.
pi,
There are
this
no
is 2 pi.
practices after school tonight of any kind. No practices after school tonight. We have 2 dances this weekend. I want you to pay special attention to this. 2 dances. One for middle school tonight, one for high school tomorrow. I don't want you to get confused.
Do not leave when the bell rings.
dance
I'm holding you
tonight,
hostage.
the middle school dance is postponed until Tuesday the 18th. That's next Tuesday from 6:30 to 8:30. The middle school Valentine's dance postponed from tonight to next Tuesday, 6:30 to 8:30. Now, the high school winter dance tomorrow night, it is still on. The only thing we've postponed is the middle school dance. The high school dance is still on. If the weather, if we have more complications, we will announce on WRAB 94.3 if we have any changes tomorrow. But the high school dance is on, and we intend for it to stay on. You can also access the principal's Twitter account at PuckettKI if you want to. We would post them on WRE.
Follow me on Twitter.
Put
I'm
it on
cool.
Twitter. Regarding the high school dance tomorrow night, no outside guests who are not already approved. If you have not approved your
Do
guests
not leave.
ahead of
The bell's
time
gonna
by
ring
this
and I don't
point,
care.
by right now,
Stay.
no outside guests will be approved.
Yes.
Students coming to the dance tomorrow night. We
Please
have
quit
to
talking.
install the lot, park in the west lot.
I'm recording all
That's the
this.
lot out by 231, the west lot, or the south side of the building, and you're going to come in door 10 for the dance. Down there in the 6th grade hallway, door 10.
Please.
People come to the dance tomorrow. Your rides have to be here by 10 o'clock, and there's a consequence if your ride is not here. We are not going to continue to have chaperones stay an hour after a dance those of you who don't drive and you choose to tell your rides to come late, have your rides here when the dance is over. Putnam County Emergency Management has issued a travel advisory for Putnam County. We've gotten the heaviest part of the snow this afternoon, so be very careful tonight after we dismiss. All right, thank you very much.
Why is he acting like we're dismissing right now? Are we dismissing right now?
Just for that.
We're still going to 7th hour, right?